Howdy everybody in YouTube land. Here we go for round two. I believe this is the older version of the same amplifier that I did in the last video, the 81000D. I took a quick look at this amplifier already. I don't know exactly entirely what's wrong with it yet. I did see the blown power supply transistors, which, if I'm not mistaken, that's the only thing that I saw. So I wonder, I'm getting ready to check now, because just like the last video, I'm wondering if I already know the cause. So let me pop this out real quick. Of course, doing this single-handedly is no fun. I'd really feel for anybody that has lost their arms in battle, or if they were born without a hand or something, because this would just absolutely not be fun. See, that was the sticker I'm talking about. See how it's broken? The other one wasn't, but somehow they were able to fool that it was broken. Ah, we got a blown capacitor. That's right. Yeah, I wonder what caused that. I wonder. Wonder if someone tried to run this at the wrong load or something. Just like the last one. Because again, you got blown power supply transistors. Take all of my screws out of here that I just kind of threw in here. Obviously, I can't power this thing up without checking all of that. So let's just make sure that it's not in there. There's probably more, but I gotta pull this board out anyway. It's not like it matters. Output transistors, I already checked them. They are not shorted. So let's check our famous diode that's always cut out and removed. Wow. It's not been modified. I'm surprised. So they weren't running this at 1 ohm. Because if they were, they would have cut that out just like the last one. But they did not run it in 1 ohm. Do we have the typical loose RCAs? No. They're not loose. This button, actually this button's pushed in when normally it's not. One difference between this model and the last one is it doesn't have the phase switch 0180. Because what that switch is for is you can run two amplifiers together in a bridge tied load configuration. So you can run only a 4 ohm speaker, but you can run one half the speaker here and one half the other speaker. So it's split, and each amplifier sees a 2 ohm load, but you can't take a 2 ohm speaker and do the same thing for obvious reasons. So yeah, it's got a blown capacitor, and it's got bad power supply transistors. So my guess, the only thing that I can think that would cause that is, again, it was run at the wrong impedance, or it was run very, very, very hard, had a very hard life. And the screws are missing out of the terminal blocks. That's so common. People take them out and lose them. I don't have them or even know where to find them, so I'll leave that up to the next person to figure out, the installer. But yeah, I don't see that same modification that most of them have. So nothing that I can see stands out at me that could have been damaged. I gotta check that. Yeah, every once in a while, it's rare, but I have found amplifiers that the MOSFET here goes bad. It's not that common, but sometimes it happens. This power supply here, just like the JL amplifiers, they use a separate power supply to generate the low voltage rails, the plus minus 12 volt, plus minus 15 volt rail for all the op amps. Cheaper amplifiers just take the main rails and put a couple of series pass transistors on there and some Zener diodes and get your 15 volts that way, but that's inefficient. They use a separate secondary power supply for that. Um, I don't know if that's a self-oscillating power supply or if they're just feeding that one from the drive signal from over here. Don't know entirely. And of course, the older these amplifiers get, the more that these aluminum electrolytic capacitors are going to become an issue. You'll start seeing them leaking and drying out and becoming a problem. So that's one thing to keep an eye on in the future. So in the next 10, 15 years, maybe even less, just keep an eye on those, because those are next. No output filter cap issues, a blown top. These are the input filters from the 12 volts. These are the rail filters. Well, nothing that I can see. So we'll just go ahead and proceed as normal, like the last video. Same as last time. Put the transistors in, anchor the board down first so it's lined up properly. Put the transistors in and tack them in so they're in the right positions. And the other thing too is after I get that done, I got to change this capacitor. But yeah, this one is pretty much just the same as last time. The only difference is there's a really annoying sticky pad up underneath those two capacitors, which makes it hard for the board to come up. But is what it is. Alright, got the new capacitor in. The old one was fairly shot and it rattles, you can feel it. So new one is in, the new sill pads are in, new transistors are in, soldered down, so it's time to get the heat sink clamps back in place, and then let's do our first power up test. Now we're ready for our first power up test, which is going to be interesting to do because I don't have any screws. I mean, this is it. That's all I have. Yeah, this is going to work out about as well as I expect. So let's go ahead and get our remote circuit in. Yay! Idling about the same as the other one. The Class D circuit's running. We have rail voltage. We're good. Wow. Okay. First power up's good. So this one just blew up just to blow up. Well, judging by how bad that capacitor was, I'm going to say that it was run on a bad impedance load. Or the speaker blew up, shorted out, and the protection circuit couldn't catch it in time. Who knows what happened. Regardless, it powers up now, so let's do an audio test. Alright, while I'm waiting for my phone to boot up, old phone to boot up, we're just about ready to roll with the test. Log into my phone. I don't want to show the password. Alright. Not that it matters because this phone doesn't work anymore anyways as far as service goes. Alright, let's see here. Function generator. Let's turn our power on. Oh, yep. We have sound. Alrighty, let's see. Library. Pull up the old, wherever the hell that file is. And by the way, the music I use for this is totally random. Whoa, I don't want to blow that speaker. Didn't hear punch the sub out of that one. Good enough. Alrighty then, well, that was a rather simple repair, so that concludes. I didn't even have to solder this one. This one's still nice and tight, so that pretty much concludes this video. It was a quickie, it was a short one, but some of these go that way, and that's the way I prefer it. I'd rather have these simple and not be completely modified to hell and back and exploded from that. Anyways, thank you for watching. Feel free to leave a comment if you have one.